Yes, others, if you have any disturbance, you can put it in the chat also. In Zoom, there's a chat windows there. You can post your question in the chat if you have any difficulty in speaking. Otherwise, you are open to talk also, please.
So, good evening, sir.
Good evening.
Sir, myself Prasad Bishetty, and I am working as assistant professor in KLE Institute.
Okay.
So right now I'm guiding a project for our UG students, sir.
Okay.
So where we are doing the comparison of different self-curing compounds, PEG 400, PEG 4000, like that.
Okay.
So in that, I just wanted to compare the hydration. What is the percentage of hydration each of them at 20 days as well as for 56 and 96 days, like that.
Okay.
So what we are thinking that to make use of the calorimetry method to decide the heat of hydration, and how can we include the SEM in that, whether through the images any hydration properties can be
No, you're working with concrete or paste?
Sir, actually for we are working with concrete, but the same percentage of mortar will be prepared, and we are extending that to the microstructural studies, sir.
No, so you're working with concrete and you're making a mortar with the same proportions.
Yes, sir.
That means with just the cement, sand, and the water.
Yes, sir.
And then you're adding the internal curing agent, I guess.
Yes,
right?
sir. PEG 400, 4000, like that.
Right. So these are basically super absorbent polymers, right?
Okay.
Correct?
Yes, sir.
Yeah. So, and these will supply the moisture over time for internally curing the concrete. So what you want to look at the degree of hydration of the cement in the presence of these polymers.
Yes, sir. Exactly.
Okay. If you're doing calorimetry, I think it has to be done on paste, unless you have a system that can also work with mortar.
Yes.
You have a.
We don't have it, sir, but I need to go it for NITK Surathkal.
Okay. Yeah. Yeah, in some of the isothermal calorimeters, they also help. I mean, they also have cells where you can actually put mortar instead of paste.
Yes, sir.
So you can directly determine the heat of hydration. If you are looking at the extent of hydration, the other possibility could be that you can also check the bound water content in your sample.
Bound water content means how much it is.
So that means how much of the water has been utilized for hydration. So the expectation is that when you have an internal curing agent, the moisture will be supplied and it will continue to hydrate the remaining cement. That's what the idea is. So as a result, the extent of bound water should continue to go up. So this bound water content determination, you can do it by two ways. One is by using thermogravimetric analysis, TGA, about which you would have learned this in this course. But you can also do it in a simpler way by using a furnace.
Furnace.
Yeah. So you take a sample of your concrete, and if you heat it to about 105 degrees Celsius, you'll remove all the free water.
Yes.
And then after that, take that same sample and put in the furnace, and you heat it up to about 600 degrees Celsius. The bound water will also go. Right? So you can then determine what is the increase in this bound water content between 105 degrees and 600 degrees. This can be done.
The weight difference that directly gives the bound water content.
Correct.
So that, this is feasible, sir, for us actually. Whatever the facilities.
It's easier rather than going for SEM or thermogravimetric analysis, which requires sophisticated equipment. You may as well go for a furnace-based determination.
Thank you, sir. Thank you.
Yeah. Welcome.
Good evening, sir. Pune Chandra Rao, sir.
Good evening. Hello.
Sir, actually, I'm a student of PhD, sir.
Yeah.
I'm in the army, sir, and pursuing my PhD parallelly, sir.
Okay.
Sir, last time also I had spoken to you regarding the superabsorbent polymer in roller compacted concrete, if you remember, sir.
Okay. Yeah.
That same line, sir. So, is there any sensors or any device which we can embed it into the concrete specimen or the sample so that I can get the graph sort of thing where the continuous hydration is going on, or the moisture content has increased or decreased, some sort of thing like that, sir?
No, there are moisture sensors you can embed in the concrete, which can help you understand the internal relative humidity. That is available, but it's not that easy to set these up. So you can set up internal moisture sensors. The advantage of that would be that if there's super absorbent polymer, it will maintain an internal moisture level which is always very high. So that would be the advantage of using super absorbent polymer, and that you can actually measure that using the internal moisture level meters, moisture sensors. That is.
Okay, sir.
Okay, there's one query in the chat box from YouTube. Okay. Sharon Alfonso has asked, this question is about the use of stainless steel reinforcement in concrete. Since coefficient of thermal expansion of stainless steel is higher, would it lead to cause and cracks due to heat of hydration of cement? Okay. And now, of course, when cement is hydrating, it's going to evolve heat, and that will increase the temperature of the concrete. And the concrete is going to, obviously, in response to the increase in temperature, there's going to be an expansion in the concrete. The question is, if the coefficient of thermal expansion of stainless steel is much higher, would it lead to cause in cracks due to heat of hydration? Okay. Now, in the expansive stage, we are not really that worried because concrete is still in the early stages. But when it starts contracting back to its normal temperature, in that case, the contraction that will be resisted by the steel, and that may lead to some stresses in the concrete. Now, I am not very sure if coefficient of thermal expansion of steel, stainless steel, is much different, right? Because normal steel has almost the same coefficient of thermal expansion as concrete. But I'm not very sure about thermal expansion of stainless steel. I'm just doing a Google search to check that. Yeah, thermal expansion coefficient of stainless steel is 10.4 into 10 power minus 6. So it's not that much different, almost the same. There is really not much difference in coefficient of thermal expansion of stainless steel and concrete. So it would work as well as ordinary reinforcing steel because almost the same level, right? I don't think there is any difference between concrete and stainless steel thermal expansion coefficient. If there's a major difference, it will be a problem, but at least from the data that is available, I could quickly pull it out from the internet that the stainless steel thermal expansion coefficient, depending upon the grade, of course, in certain instances, you can have a high thermal expansion coefficient for certain grades of stainless steel. But in some other cases, I really don't see too much difference, right? Okay. Any other queries, questions? Because your exam is coming up in a couple of weeks, or not, 3 weeks rather, right?
Sir, I would like to ask one more question. That
sure.
is regarding the study, what I'm carrying out.
Yeah.
So I'm just assessing the potential of making use of ISF slag, that is the Imperial Smelting Furnace slag.
Okay.
And the suitability of that for the PQC concrete, sir, pavement quality concrete.
Okay, sure.
So based upon the literature review, what I have conducted, I came to know that some of the authors has mentioned like it is going to affect the setting time. Somewhat delay in setting time has been observed.
Okay.
Due to the presence of heavy metals like lead and zinc.
Right, right.
But whereas some of the authors has mentioned that there is no such incident has been reported or as such things has been came across. So to draw inference between these two, how I can verify that whether it has effect on the setting time or else not? Because when I have casted the cubes and tested it for the next day, when I have demolded it, I have not observed any delays in setting time.
Yeah, generally, I have not seen literature which talks about influence of heavy metals on setting time. And I don't expect there should be anything on that. The only thing is, these heavy metals, are they having a potential to leach out in the long term? That is the only danger. But usually in all the cases when concrete is used, the CSH is able to actually bind the heavy metals and prevents them from getting leached out. So I don't think there's a problem with respect to that also.
Okay, so then the only concern is at the end, if we need to do the USPA leachability test, and if it is well within the limit, then we can proceed.
Exactly. Correct.
Fine. Thank you. Thank you very much.
Yeah. Nilakanmani, any other questions from the
Sir, I have a question. I'm posting it from the discussion forum here.
Okay.
Just post yes.
Yeah, so there's a question from the forum. Whenever we want to take the BSc of the specimen, what should be the specimen? Minimum, maximum size we need to provide. Okay, in any microscopy, of course, we have to limit ourselves to very small specimens, right? Because the microscope can only take any instrumentation will not be able to take very large specimens. As large as possible is obviously an important way to look at it. But given the sizes of the instruments and the chambers and the extent of sample size it allows, that will be the restricting factor. It's not going to be possible for you to fit in very large sized specimens. So generally, maximum size I've seen of specimens used in SEM range from about 20 to 30 millimeters, not more than that. 30 is the largest size we see. And if you're going to be including steel, it has to be taken from the interface between concrete and steel, because that's what you'd be able to study with 30 millimeters size. That I don't think it will look at much more larger than 30 millimeters in scanning electron microscopy. A question regarding AAS. Is AAS used in cement concrete research? If so, how to vaporize the cement paste? Okay, now in AAS usage in cement and concrete research, the idea is to actually look at it as a tool for understanding either the chemistry of the cement itself in terms of the alkalis, or in terms of understanding the composition of the pore solution. So in either case, the alkalis or the other elemental compositions that you'd like to determine need to be brought into a liquid phase first. So that you can do by mixing cement with water and taking the soluble species that have dissolved into the water and using that water to do the analysis. Alternatively, you can do a pore solution expression where the concrete after hardening can be pressed triaxially to extract the pore solution, and then you can do an analysis of that by diluting it further. So you have to do it on a liquid phase. So there is an aspirator which takes the liquid and then puts it into the furnace, which basically vaporizes and then gets it to a level where atomization of these elements, sodium and potassium and all that is possible, or magnesium and calcium is possible. And that is then detected using EAS. So from solid, you need to convert to liquid phase, and from liquid to the atomized phase inside the furnace. Any other queries?
We could not find any more queries, sir.
Okay, not in the forum also? Forum, you have
Not
answered all the questions?
So only one question was discussed. Since we have live sessions weekly, so not much questions in the discussion forum.
Okay.
I could not find a YouTube link, sir. If possible, if there is a link, within a minute, I'll check and tell you.
Yeah, I just posted the YouTube link, and YouTube also there is no questions. Only one question is there.
Yeah, only one was there which we already answered. Okay, sure. There's only two people watching. Okay, right. Okay, I guess if there are no further questions, we can close the session today.
Yes, sir, we can, sir.
Yes, sir, we can do.
Okay. Well, at least to those who came, thank you all for joining.
Thank you very much.
Thank you. If you have any further questions, you can always post them on the forum. We'll answer as much as we can. Sure.
A kind request, sir. One more thing.
Yeah.
So we have completed already the advanced concrete technology, that course also, and this is also very interesting. Only the thing is, I just want to request if any another course is getting introduced. So try to introduce life cycle assessment of the concrete, particularly materials. That part we are lagging, sir, and we are not able to concentrate or get the accurate things in the websites also, where we need to learn those things, especially related when we use some types of slags and the materials which are related to the concrete. So if anything you get, just advise us. We'll go through the materials.
So we have not yet planned a course that has covered the content on life cycle assessment, but I'm sure that this will happen in the future.
Yes.
My colleague, Professor Ravindra Gettu, is doing a lot of work in that subject. And definitely, I think we should have some lectures coming up on that. Actually, there's going to be a short course on recycled concrete that will be introduced in July. That will have a segment on life cycle assessment also.
Fine.
So you can look out for that. That's a 4-week course, short course. So you can look out for that. But that's not a completely on life cycle assessment, but it will talk about LCA from the perspective of recycled concrete.
Fine. Thank you, sir.
Okay. Okay then. Right. Thank you all. Thanks very much for joining.